Good evening, ladies and gentlemen. I would like to welcome you to today's Science Café. My name is Lenka Zychová and I represent Czech Liaison Office for Education and Research here in Brussels, and which is part of actually Czech National Agency for Education and Research. We have been preparing Science Café for you for several years already. It's an informal event which aims to bring science and research more close to public. It's also take place quite often in an informal space to make sure that actually the discussion will be as open as possible. And we hope that you will enjoy the evening. Today, the theme of the Science Café is actually weather space, and we are really pleased that our invitation was accepted by Lenka Zychová. She's a Czech scientist researching the topic, and also Vera Pinto, who will moderate the whole Science Café today. But before I will let them the floor, I would also like to thank our colleagues from the representation of South Moravia region, and also colleagues from Czech Center who are organizing the Science Café with Cello today. And after the fruitful discussion I hope we will have, you are also invited to a glass of an excellent Moravian wine and some small snack. So right now I would like to invite ladies to join me here. And I would like to pass the word to Vera. Enjoy the evening.
Thank you very much, and thank you for the invitation. Welcome, Lenka. And before we start our conversation, I would just like to share with you some rules of the house on how we are going to proceed during the event. So me and Lenka, we will have a small conversation about space weather. That is actually a very fascinating topic, and that will last around 40 minutes maximum. And after that, we will open the floor for questions that you might have around the topic and to Lenka. So I will let you know, of course, when we are reaching the end of our conversation. I promise that I will refrain myself of making a lot of questions and giving you the opportunity to ask anything that you might feel like about space weather. So today we are having this conversation with Lenka. I will not try to pronounce your surname because I'm Portuguese, so that means I will most likely not pronounce it correctly. So Lenka is an astrophysicist who currently works actually as space weather scientist at the Royal Belgium Institute for Space Aeronomy in Belgium. And in case you don't know, Belgium is actually one of the European countries that is more active on solar and related research, and considering the amount of cloudy days that we have in Belgium, this is actually quite funny. So Lenka works primarily on ESA's Space Weather Service Network project. She provides forecasts and information about space weather to people and companies whose work is actually sensitive to space weather. And we are talking about spacecraft aviators, but also aviation companies, for example, power grids operators, etc. Lenka received her PhD in astrophysics at Masaryk University in Brno, okay, where she focused on interstellar matter. This is actually quite interesting. But I also think that you have quite an achievement, because Lenka received the British Council and a Neuron Award for Science Outreach. And in fact, we were just talking before we started on this awesome project that Lenka is now coordinating about taking space weather and developing space weather educational materials for children with vision impairment. So I think even in space we can work in inclusion and everyone can observe space. But today we are talking about space weather. And I think probably one of especially for the non-space people that are here in the room, I think the first question is, what is space weather?
Thank you. Good evening, everyone. Thank you, Vera, for the introduction. Indeed, what is space weather? Normally, space weather is the state of environment of the of the near space. So if I can draw an analogy to classical weather, classical weather says what is the state of the atmosphere. So it describes if it's cold or hot outside, if there is storm, if there is rain, if there are strong winds. Space weather actually describes something similar, or we use similar language. You can know if there is enhanced radiation from the sun, if there is a, let's say, a rain of energetic particles, if there are strong solar winds, if there are any solar storms or geomagnetic storms. But of course, you experience classical weather on yourself. You just go outside and you can feel it's hot, it's cold, there is a rain. I hardly think that anybody of you would just go outside and shiver and say, today is very strong solar wind. Nothing like that can happen, of course. So what I want to say with this, we do not experience the space weather impacts on our body that much. You can be in space, then yes, you would have some impacts on your body. Or even if you travel by airplane, there could be already some effects over there. But usually we experience the effects on our technologies and our infrastructure. So it doesn't mean it has to be only in space. Our technology, we can have some consequences over here on the ground from the space weather.
This is very interesting, but I think if you could explain a bit more, what is the source of space weather? So where this all come from?
Indeed, so the main source of space weather here on Earth is our sun. There are of course sources in the deep universe, for example, explosions of supernova. If you never heard about supernovas, these are really massive stars, thank you, that end their life, so they can explode, they can produce some, not only classical electromagnetic radiation, but some energetic particles. But also, for example, when you have supermassive black holes in the center of galaxies, so the surrounding environment can produce really like flood of energetic particles. These are sources of space weather as well, but today I'm not going to talk about it too much. If there are questions, I'm very happy to answer. But the main source is our sun. If you would be on a planet in a different solar or stellar system, that you would be on a planet that orbits another star, of course, then the space weather would be influenced by that star. Our star, sun, is pretty active. It is not as active as other stars, but thanks to the fact that it's really dynamic, we can have it as the source of space weather. So for example, there is constant stream of energetic particles from our sun. We call it solar wind. This solar wind can be pretty fast, sometimes around 750 kilometers per second, not per hour, but per second. We can also see some solar flares on the solar disk. Solar flares are actually eruptive events on the sun that can produce a lot of radiation, classical electromagnetic radiation, but also energetic particles. When I say electromagnetic radiation, I'm sorry, I'm not sure how much I have physicists here and not. So if I say electromagnetic radiation, is it like yes or like meh? Meh. Okay, good. Thanks for the feedback. It's good for me to know. So electromagnetic radiation, it sounds really like horrible, but actually it's what you see in your eyes right now. So all the colors that go to your eyes, you can imagine this electromagnetic radiation to be just a flood of photons, particles, and they have energies, and each of the photon has different energies, and according to that you can see different colors. So for example, I see beautiful blanket, red blanket, it's from IKEA, I think. I have it at home as well. So that photon that comes to my eye has slightly less energy than the photon that comes from my blue dress to your eyes. And then there are particles, photons, and that have lower energies than the red color. We call it infrared. You probably heard about this one. Radio waves as well. So even the radiation that transfers a radio signal and the radiation that goes to your eye is the same but different energy. And then you have radiation with higher energy, like X-rays, gamma rays, ultraviolet. Okay, so it is again the same photons but different energy. So when I said that there are some eruptions on the sun, you can imagine that thanks to this eruption you have a flood of these photons. Some are less energetic and some are really, really energetic, like X-rays or gamma rays. So that's one source. Or a second. And third source directly on the sun is called coronal mass ejections. And to imagine that, just imagine the chunk of sun is taken away and can go towards Earth. So the chunk of sun, it's not that piece of sun really gets away. We talk about billions of tons of plasma, but according to how heavy the sun is, this is like nothing. However, this chunk of plasma, when it goes to Earth, it is not just the material, there is also magnetic field that is frozen in this plasma, and that can cause a lot of problems here on Earth. So just to remember, our sun is active, and all the stuff that happens on the sun causes our space weather over here.
I think by now everyone in this room is thinking, oh my God, there's chunks of sun coming towards us. Should we panic? And then this leads me to the other question, that is the Earth protected? How? Because you were mentioning a bit before that we have all these things happening with the sun and coming towards us, but affects technology, but not us people. So is the Earth protected, and how?
Indeed. If we would be on Mars, it would be a different question. So here we have two important things: magnetic field of the Earth and the atmosphere. So magnetic field is really important in the sense that if you have some energetic particles, they can be redirected thanks to the magnetic field away, so they do not protrude to the atmosphere. Some of them do, but most of them, they really nicely follow the magnetic field lines and go kind of away. So that's first thing, magnetic field. Second thing is our own atmosphere. It's atmosphere is really something we should take care of, because it protects us from the harmful radiation, like ultraviolet radiation. That's why we have ozone layer, because in that layer the ultraviolet radiation is absorbed and creates ozone, simply said. We have also ionosphere. That's another part of atmosphere that actually absorbs X-ray, gamma rays, and creates this layer of electrons, let's say. And that protects us as well. So this is one thing. And also, if there are any charged particles going towards the atmosphere, they can be stopped partly in the atmosphere. But of course, if you are higher in the mountains or by the plane, you get more of these energetic particles. And maybe why am I so obsessed with the energetic particles? Because these can do harm to your own body. They can get into the cell. They can actually damage, if they have high energy, they can damage directly your DNA, for example. So that's why we are so obsessed about the energetic particles to stay away from us.
And just for curiosity, because you were speaking also that it would be a different story if we would be in space, and in fact, satellites and even the International Space Station, that is where we have humans in space, they have this type of special aluminium foil around to protect from the sun radiation, also because of this, correct? And when did people understood for the first time or realized for the first time that all this activity was going on the sun? Because for many years we thought that actually the Earth was in the center of the universe, then we changed our views to the sun is in the center of the universe. But at a certain stage we had to, how did we realize that actually the sun was having all this activity and all this energy coming towards Earth?
So knowing that something is happening on the sun, it's really long time ago, but to know that what's happening on Sun influences us, we think about the Carrington event that happened in 1859, in September 1859. And what happened that day was that people across the globe suddenly observed these strange lights on the sky. Now we know these are auroras or northern lights, but people are really surprised to see them, for example, as low as Mexico and so on, because normally you don't see northern lights there. And they were really, really confused. Many of them thought that there is a fire in the town across the river, or there were some accounts that people even were able to read newspapers under the light of these lights on the sky. It was so strong. Even the gold miners, it seems, according one of the account, they woke up because of these northern lights and started to prepare their breakfast because they thought it's morning. And also, unfortunately, there were 3 birds killed. And I know it sounds like, what are we talking about? So indeed, there were 3 birds, larks, if they are Czech people, skřivan. They were chirping because they thought it's morning. So they started to chirp, and some person was really angry and couldn't sleep, so he shot the 3 birds. So this happened as well, so we have accounts on this. However, there was something bigger happening as well. Back then, there was a telegraph communication, and suddenly the telegraph communication just stopped. It was impossible to communicate. On the other hand, some of the operators found out that their system worked even though it was not connected to batteries. So they could communicate, but they didn't have the batteries connected to the system. And they said it worked on electricity in the air. Also, some witnessed sparks coming from the cables. One operator was actually got electric shock in his forehead because he was bending over towards the cable, and there was really big spark. He survived. So this was really big. But one more thing happened. Back then, astronomer Carrington, he was observing the sun, and you don't observe sun through the telescope right away, or he didn't. He projected it on a desk. And suddenly on the sun, he saw this white little flash. And he thought it's just a beam of light going through some hole or some problem. Typical scientist, when you think all about the mistakes, but then he realized it's truly happening on the sun. And what he observed was the first solar flare ever. It was such a big solar flare, this eruption on the sun, that it was visible even in white light. That's really something unique. And that's when, back then, people connected what happened on the earth with the sun. Mm-hmm.
This is actually quite interesting, and this was in 1859. We are now in 2022. So by now, okay, I'm pretty sure, I hope at least, that we don't kill birds because there's a solar flare. So that would be already some progress. And we actually need to preserve biodiversity these days. We need to protect the atmosphere and also the biodiversity. But I'm wondering what other type of impacts we now know that this solar activity can have.
There is another effect connected to what I was saying about the telegraphs. It's power grid outage. So for that, I will borrow another event from 1989. Back then in March, again, people observed northern lights everywhere. There were problems with radio communication. Radio Svobodná Evropa, Radio Free Europe, couldn't broadcast. And people thought that Soviet Union was jamming it. But no, it was through the sun, actually. That was the problem. And then many other things happened. Polar lights. And people were really scared that it was attack from Soviet Union, that it was a nuclear weapon used. Because, again, they saw these northern lights in places that they were not normally visible. And what also happened was that in Quebec, in that time, in March 1989, 89, suddenly the power grids just stopped. They had outage for 9 or 12 hours. They were without electricity in a cold Quebec in March. And this was not just easy technical problem. The problem was that the transformers were, some of them, so damaged that they couldn't work. And I would like to actually explain why this happens, how to connect what happens on sun that suddenly you don't have electricity. So you remember the chunks of plasma from the sun coming towards the Earth? It's a magnetic field, and it can interact with the Earth magnetic field as well. And you can imagine that the Earth magnetic fields, I will say shakens, or there are some disturbances in the magnetic field. And if you remember from the basic physics classes back in high school many years ago, if you have a conductor in a changing magnetic field, you have electric current going through the conductor. And this is really important, because if the whole Earth magnetic field has some disturbances and it's, let's say, shakes, vibrates, our grounds under our feet are also conductive, and it triggers electric currents in the grounds. And these electric currents can create another electric field and get the currents in your long conductors, like the telegraph. So that's why back then in 1859 was the problem with the telegraph communication, because there was such a chunk going towards the Earth and did all of this. And in Quebec, 1989 was the same problem. This chunk of coronal plasma came towards the Earth, and the magnetic field was disturbed, created currents in the ground. Some of the currents got into the grid, into the transformers. And what happened was that some of the transformers, I will say burned, but it's not that they were in flames. Some of the isolation burned and they couldn't work. One of the transformers was in New Jersey, and it was so damaged that it just couldn't work ever. And to replace such a transformer, you usually would wait for a year. This is not something that is stored anywhere, but they were lucky because there was another plant close by that had the same type of transformer. So already in 40 days they could have a replacement. But it was a really major event. Mm-hmm.
And just have a final question before we pass the floor to the audience. So if you have questions, please start preparing yourself. I'm sure Lenka will gladly reply to any question that you might have. That is the question of the direct impact on humans, because, you know, I think all of us, we are still on the part of massive chunks of sun coming in our direction. And you were saying that you even can change DNA. So can you speak a bit more about this direct impact in humans so that we can reassure the people that are here and following us at home that we are still safe?
Of course. So you don't have to be worried unless you walk on the moon, for example. So you can stay calm. But no, there's another important impact, and for that I will use another event from 1972. Again, a lot of things happen on the Earth. Lost radio communication, polar lights, even in close to south of Vietnam. Suddenly, 12 undersea mines detonated without a reason. Normally, if you have an undersea mine, you need a ship passing by. It changes the magnetic field a bit and the mine explodes. But then in 1979, somewhere in August, these 12 mines just detonated without a reason. Later on, we found out that it was space weather. Again, the coronal mass ejection and the disturbances in the magnetic field. But there is another thing. The August 1979, it was just between two Apollo missions. Apollo 16 landed on Earth 27th April, and Apollo 17 launched 19th of December that year. If the Apollo mission would experience this event, it would might have been fatal for the astronauts, because there was a major solar flare. It seems that it was, in our categorization, X20. it's like insane. And if the astronauts would be on a moon, doing their moonwalk, even though if they would try to hide in their lunar module, they would get really serious radiation dose. That would be around 4,000 millisieverts. Millisieverts is a unit we use when talking about radiation doses. And that would be really extreme or very serious radiation poisoning. And the fatal rate, the mortality, would be 50% after 30 days of experiencing this. So they would be really endangered. Now, to ensure people, because now I'm still like frightening everyone. No. We have the atmosphere, and that protects us from the energetic particles. However, we have airplanes, and we travel a lot, especially here. A lot of people are traveling between Brussels and other cities. Of course, more you are higher in the altitude, more particles get into your body. Normal flight is not a problem. The problem starts when you are a frequent flyer and when you do mostly the intercontinental flights through the polar regions. Why? When you have polar regions, that's where the magnetic field lines are going towards Earth. And if some of the energetic particles are redirected, that's actually the place where they can go into the atmosphere. So you can get more radiation if you're in the aircraft, especially around the polar regions. However, you don't have to be worried. Normally, even the doses are not so serious. You will not have like severe poisoning or anything like that. But if you're really a frequent flyer, you can calculate it if you want. I can give you a way how to do it. There is a beautiful tool on our website where you can calculate any flight you have and get the final dose. And this is how you can experience the radiation on your skin, but you don't have to be worried that much.
Should we always put sunscreen then?
I will not. I will not.
Okay, still put sunscreen anyway. There's other issues.
But placebo works as well. So depends when.
Well, the good news is there's also a lot of research here in Belgium about space weather. There's actually researchers here studying the impact of radiation in space to develop medical treatments on Earth, including for cancer. So there's a lot of research also. There's also a positive thing. So we can still go outside, right? Atmosphere is there for us. We just need to keep it and to protect it. So I would open the floor for questions from the audience, from here and from back home. So if you would like to ask a question to Lenka, just raise your hand so that we can give you a microphone so that everyone can hear your question.
Hello. Is this working? No. Not working. I don't think so.
But for online people, it does work.
Does it really? Okay.
Yeah.
So that's perfect. Perfect. All right. Thanks for what has been mentioned so far. I'll try to follow up on the last point you made about the harmful impacts of space weather you can experience us as humans, but also technology here on Earth. But I'd like to take this one step further, maybe towards the impact, or maybe how we can harness space weather in space, actually. How the technology can benefit potentially from space weather. I mean, there's been a discussion, and I'm not quite sure if this taps into your expertise, but I'm sure you've heard about cases of thinking about using space weather, in fact, solar winds, for example, with solar sails for satellites, probes. Are there other examples of benefits of space weather in this context, or? Thanks for the answer.
Nice question. Actually, indeed, this is not my expertise, but what you mentioned, the solar winds, indeed, they can be used for the for traveling. For another example, I'm really trying to think, but it doesn't come to my mind at this point, unfortunately. But studying space weather is super important. especially for the space flights, as we partly touched it, because that's what endanger you mostly when you travel. Already in the spacecraft and then on the planet where you land, yeah. But this is a very nice example that we can actually use space weather, especially the solar wind. But as I said, this is not completely my expertise. Yes, please go on.
If I can complement, you also need to take into account that the study of space weather is also very important to protect infrastructure that is in space. So for example, all the satellites with an event like the Carrington event, it would mean that life as you know what is today would cease to exist. Stock exchange will stop, cars, trains, the electricity grids, everything, all the networks, they would stop because these days they all use space state and space services. So that would mean that if there's a big solar flare, we need to be able to try to protect our infrastructure, because infrastructure that is in space is the one that is most exposed to it. And we also use the sun to keep our satellites in orbit, because they all use solar panels, and that is what they keep them moving. And so if there's no sun, it means there's no energy, satellites will stop operating also. And then the things that you mentioned, like the solar wings, this is actually already talked for many, many years. But there's always an issue, that is the technology is not there yet, is not developed yet, and then it's like a tango, you need two to dance it, right? So you need the technology to be developed, and at the same time you need the money to develop that technology. So if one is missing, you don't dance the tango. So then it's all about, the priorities for research, where the money coming from, etc. And I think we had a very good example when everyone wants something, it happens quite fast and quite efficiently. And we saw that in the last 2 years, for example, with the research that was already into place, but suddenly everyone put the money, everyone joined the brains, and magic happened, and we had a vaccine in 1 year or 2 years following all the rules necessary. See? In space, sometimes we don't have that. So you can have the brains, but you don't have the money, or if you don't have the money, if you don't have the brains, it doesn't happen. And the solar wings, and among other projects, even related to space junk, for example, sometimes this is what is happening. Even with space mining, for example.
Can I compliment? Indeed, I absolutely agree. Sometimes what can help is military at the end, because if it starts to influence military, then suddenly, bam, the money is there. And for that, I have one event that I would also like to mention. This is unfortunately very related to what's happening nowadays. It's pretty strange for me to say it at this moment, because normally, like 2.5 weeks ago, I was giving a similar talk for, it doesn't matter where, in Czech language. And when I was saying this story, I really enjoyed saying it because it's fascinating. You are going to hear that in a bit. But now it's just doesn't feel good. But I'm going to say it to you guys. So in May 1967, when it was still in the middle of the Cold War, there was a major thing happening that nearly caused a third world war. Just the background, you can imagine Cold War, this is already something, big tensions, there were many other international conflicts. Now, on 15 May 1967, the US military updated their BIM News. BIM News is Ballistic Missile Early Warning System. And the update meant that now they were detecting any missile coming on a specific wavelength or frequency 440 megahertz. Okay, this is just an information. That happened 15 May 1967. 22nd May. That was the beginning of the 6-day war between Egypt and Israel. So again, huge tensions, 100,000 soldiers sent to the Sinai, a lot of things happening. On that same day at 2 p.m. UTS, Soviet Union launched something to the orbit. US military didn't know what. Now we know it was something like a spy satellite. 2 or 3 hours later, US military also launched something, and Soviet Union didn't know what. Again, something like a spy satellite. But you know that the tension was really high. There is this conflict. Everybody's launching something to the orbit. When at 6:39 p.m., suddenly the radio communication stopped with your aircraft in the air for the U.S. military and everyone actually there. It took them an hour to get the radio communication back, not just with the aircrafts, but also with their own satellites. There was a problem. The communication didn't work as it should. Finally, they got the radio communication back, and 15 minutes after, it was gone again. And suddenly, they got a signal on this BIM news, the ballistic missile early warning system, that there is something coming to United States. A huge signal. So back then, the response of military had to be in 15 minutes. So normally the pilots were in the bombers, they were ready to launch. They were just waiting for Pentagon to say yes or no. So, and as we are talking about space weather, you can imagine who was the villain here. It was our sun. Because what happened, there were several solar flares. One of them caused the loss of radio communication. That works in the way that, if you remember half an hour ago when I was talking about our atmosphere, about the ionosphere, that is this pretty big layer of special part of atmosphere, let's say. We use it in radio communication in a way that the signal can reflect and go where we need. And suddenly this ionosphere was disturbed by these solar flares, because suddenly you have a lot of radiation coming from the sun. So there are changes in the ionosphere, and it didn't reflect the radio communication. But one of the solar flares also produced this huge radio signal that was never ever observed before. That's why they tried to do the ballistic system, early warning system, on the frequencies that nothing can jam it from natural sources. But yet, our sun, bam, such a signal. But as you know that there was not Third World War back then, what happened was that NORAD, North American Aerospace Defense Command, called to the weather office and asked if by chance there is nothing with the sun. And as meteorologists, the weather office was like, yeah, we don't care about sun, we take care of the atmosphere. They called the solar department that existed only for 1 year. So can you imagine if it wouldn't exist? And they told them, literally one of the officers who was at work, he said, yeah, half of the sun blew away. Of course it didn't happen, but it was so much activity on that day. So thanks to this solar department, they didn't go with the mission. Because of our sun. Yeah, so this is also another impact that can happen.
Once again, no need to panic. There's a lot of solar weather forecast, and like I said, Belgium is one of the major countries in Europe following this, and we have the best expert here with us today to explain us this. Is there any more? Is there more questions from the audience?
Hello. And thank you very much for the great discussion. Actually, you've already touched upon the topic, so we're talking about weather, and of course, what everyone is keen to know is about weather forecast. So, you know, what sort of things can we actually forecast in advance? I know, well, maybe some people know that there are some kind of, cycles of the sun that we can observe and learn from the past. Some of the events, I assume, we cannot simply predict. So, you know, what can we and cannot we forecast in advance? Thanks.
Thank you for the question. Indeed, so as you mentioned, our sun goes through a cycle that is 11 years. It is always in its minimum and then in its maximum. So we do see some rise in its activity every 11 years. Some things we can forecast, but those things that travel to us with the speed of light, when we see they are here. So for example, the solar eruptions, if we observe them is already here. There are some models that are trying to predict if there is a higher chance of the solar flare happening that day, but to predict it really advanced, let's say an hour before, this is still out of our competences. However, some things like coronal mass ejections, that's something we can observe. Yeah, so the image comes to us with the speed of light, but the material itself doesn't go with the same speed. It goes maximum 3,000 kilometers per second. So we have still time to know when it arrives and if it arrives. So for example, the geomagnetical storms, we can predict much better than the solar eruptions or solar flares that can disturb the radio signals, for example. Yeah, so as you see, we are working on it, and as you also said, we need money for that. To have better predictions and a lot of data. So not only to developing the models, to be able to put them on some real data, we need also more observations of the sun and Earth as well. There is another thing I didn't mention, and that's radiation belts. So around our Earth, not only the magnetosphere is there, but there are trapped particles that are in these radiation belts, and these are influencing, as you said, our technology, our satellites, and unfortunately there are still mechanisms we do not understand how it works. Suddenly we can see that there are these killer electrons suddenly injected in these radiation belts, and it's sometimes hard to predict if it comes, when it comes. Sometimes it comes when we really don't expect this. Talking about satellites and the problems they can experience, maybe you noticed in February Starlink had some real troubles. They launched like 49 satellites, and 40 of them didn't make it. Yes, I was thinking about good word. And the reason is, if you have a satellite on low Earth orbit, meaning about 160 kilometers and slightly above, then you can have real troubles when Earth atmosphere heats up. How can Earth's atmosphere heats up? Thanks to the solar eruptions. Again, you have a solar flare, there are some X-rays, gamma rays, atmosphere absorbs it, heats up, and what happens with heated gas? It expands, and suddenly the satellites that are nicely in their orbit, suddenly they are in denser environment that slows down their speed, and then they can deorbit a little bit lower. So that's what happened to Starlink, and they couldn't, with their thrust, they couldn't get back to the orbit they needed. So that's another impact on our technology. Did I answer your question? Yes, okay. I got again somewhere over there. Okay, good.
And just for those who are not knowledgeable about Earth orbits, we have 4 actually. The LEO, where the Starlink are, is the low Earth orbit, is around 150-60 kilometers, is the closest to Earth. Even if the atmosphere expands, it will not reach the medium orbit, that is around 20,000 to 30,000 kilometers, is where you have satellites like Galileo, GPS, satellite navigation. And then you still have the geostationary orbit that is even a bit further from Earth, where you have communication satellites, so Netflix and these type of things. And then you have a 4th orbit that is called the graveyard orbit. That is basically where satellites go when they reach the end of life. Yeah, it's really heaven. So usually the ones that are in Leo, so the low orbit, they re-enter atmosphere, and you will be looking at the sky and thinking, oh, such a nice shooting star. Most likely it's a satellite or a little asteroid, a little rock re-entering atmosphere. Most likely it can be even a Starlink satellite dying. The other ones go to graveyard orbit. Is there more questions from the audience? Oh, wow. This is what I call interest. Very good, guys.
Hi. So yeah, thanks for all the explanations of how everything can go wrong. I was wondering if with the amount of microelectronics and probably more sensitive electronics, tinier and tinier things, more and more dependencies on it. Could you give a simulation of what would happen if you have solar flares or other activities at the strength of the examples you mentioned from 1859 or 1989 or so? Mm-hmm. And secondly, if suddenly my phone stops working and some light starts flickering and so, is there any way that I could check whether it might be because of a solar flare?
Yeah, it's a good question. Yeah, okay. Thanks. If you still have internet, this is a very good point. That's okay, but then it's a very hard situation then. Okay, first question. You're absolutely correct. We tend to have smaller and smaller devices. We now create things in a nano measures. And if you have such a small device, memory chip, and you have an really energetic particle, it can actually destroy this little chip. So indeed, we are more sensitive because of this. That's true. To know exact simulation, what would happen if a Carrington event comes now, it's hard for me to predict right away from this spot, but there would be severe damages on the satellites. Could be severe damages on the satellites. For example, with the Carrington event, the satellites would be killed. I have a one example that was the event 1972, when I said that the astronauts would have severe problems. Then, thanks to the increased radiation and particle radiation, for example, Space Shuttle Discovery, that was in orbit, had a malfunction of its sensor that said that there is extreme pressure in its fuel tanks, I think. So this is a hard thing to know, because then you have to navigate and do some measures. Then there were many outages that the satellites just stopped working. There are false commands even. So yes, it can be. Yeah, there could be damage done on the satellites. And for you, how to check if something's happening and you still have internet connection?
No internet. If my internet is down,
how
do
I don't know.
Do you know how to work with those phones that you need to, like it has a little wheel and you need to pull the button? Like, you know, that was like in the 80s.
You mean?
Yeah. No, I'm kidding, but kidding and not kidding, because in fact what happens is that these days we rely on these things, right? So if a major solar flare would happen, all telecommunications as you know it, they will be disrupted because you don't have landlines anymore, right? So the good news is that a lot of people that you never heard about it before, they are actually working in what is called backup solutions, in case this type of event would happen, that we are still able to keep certain services operating, like emergency services, for example, critical infrastructure. Inside critical infrastructure, you have electricity grids, you have telecommunications, and so on. But nevertheless, if you see one of those phones that has a little wheel, and you can start keep the phone number of the Royal Belgium Institute.
You're not going to be there anymore.
and learn how to work with those phones, because then you can do a phone call. But yeah, there is even space weather forecasts like you have for when you go to your app on your phone to see the weather, if it is going to rain or sun, you have similar things for the space weather. And actually, one of the things that we didn't talk about was exactly the question of space tourism and space weather. But there was another question, so if we reply to your question.
I would like to still add a little bit, because what you just said, I want to complement. So that's what we are doing now with the ESA project. We are creating a portal that anybody of you can access already now, and you see current space weather conditions there. So what is happening? It is still pre-operational, so if you would get there, you would be like, oh, where to look, because it's a lot of scientific data, but we are creating a translation for people to understand what is happening on the sun. So there you can find, to see if it's through some solar event or maybe it's something else. So we are creating for Europe, we are creating this portal and it's already working. And if you work in some of the services that are sensitive on space weather, as you already mentioned, energy, aviation, indeed, power grids, even pipelines as well. If you work in that field with pipelines, they also are sensitive on space weather, by the way, because these currents and these different electric fields can actually cause some corrosion on the pipelines. So that's just an interesting fact. Yeah, so we are developing this portal towards these people so they can also check if the malfunctions in their services are caused by space weather or not. So I would recommend to go there. The only little trouble is that to remember the website, it's something, it's not like currentspaceweather.com or anything like that. It's like, oh my God, SSA, yes, ESA space weather. ESA space weather, otherwise it's SSA.sv, I don't know. I hope my colleagues are not listening to this talk because I should know, but I have it in my browser anyway, right? ESA space weather, and you will find it there. If you're completely lost, spaceweather.com, that's from our friends from United States, you can find information there as well. Yeah.
There was another question.
Yeah. Yes. I don't know.
Thank you very much for this great introduction to space weather for dummies. It really works for us, I would say. I'm not going to ask the catchy question on the immediate impact on human health, because we have 150 other better ways how to ruin our health other than space weather. But the fact is that human brain and heart are very much based on electricity and electric energy that the cells communicate there. If there is a major space weather event, would there be any change in values if we were, for example, measured on EKG? Or other appliances like that?
I love this question. Short answer is no, but there's a lot of fascinating thing behind this. So we don't know any, as far, what I'm saying, it's my knowledge at this point. So maybe I'm not aware of some research. But as far as I know, there is no research that would prove space weather related events to physiology of our body. However, there were experiments on if humans can sense, if changes in the magnetic field can something cause to humans, because we know that some animals are sensitive to magnetic field and they orient themselves, like birds, even dogs. There is this research. It seems that dogs do their, how is it in English politely? Yes, they do their poo in a specific direction according to the magnetic field. Yes, so if you have you can observe this, but they have to be unleashed, so they can really like decide. Measurement. Yeah, so this is pretty interesting thing, and there's also is it some kind of fox seems to attack the victim in a specific direction again according to the magnetic field. So there are animals who are really sensitive to the magnetic field. Birds even kind of see the magnetic field because of in their eye, I think the blue cells, they can actually, it's a lot of physics behind it, but they can kind of see magnetic field. So there was this research about us humans, if we can sense these disturbances. Short answer, no. Longer answer is that even if you would experience such a change in the magnetic field as the complete change of the poles of the magnetic field, then some people, it was really little fraction of people, produced a little bit more alpha waves. So they didn't feel it themselves, but the measurements showed that there were some, like a little bit more of the alpha waves that brain can produce, but this is really super small. So basically there is no impact like that. But interestingly, if you don't mind, if I share a little bit more of my passion for animals and space weather, you know, there's this airborne spiders that are actually sometimes flying. You might have seen them. They're just in the air. And there were many different theories how they do it, if they catch the wind or something like that. And you know what? They can create a specific protein from thank you. You always help me with the words. So when they created the threads, it's a specific protein that is already charged, and it follows the very thin and weak electric field of our Earth. This is fantastic. And then they're like going up, and they can go super high. And already Darwin noticed it, that he was somewhere on a ship for many days, and suddenly he saw many spiders flying around. How could they get there? And it's the electric field. So it's fascinating, I think. Oh, okay. Yeah.
Is there more questions from the audience?
Here, over here.
Yeah, my husband hates spiders.
Really?
Yeah, he's super scared. There's a spider, I'm the one who needs to do it.
If the magnetic poles were to reverse or flip, how would that affect exposure to space weather?
Oh, fantastic question. Yes, so normally if this would happen, it doesn't happen within days. It takes really long time, but the magnetic field weakens. And in that sense, there would be much more particle radiation on Earth. So we would be exposed for higher doses of radiation. So that would be one effect on us as humans. And of course, also the technology that is still within the magnetosphere would also be under attack of these energetic particles. Yeah, it's a very interesting question. Mm-hmm. Mm-hmm.
More questions? I know that everyone is already thinking on the wine, but I have one more question. And I actually will start with a question for the audience, if you allow me. That is, who of you ever dreamt in or has on his wish list to go see the auroras? Raise your hand. I already saw it. Okay, very good. So now, do you know that space weather and auroras are related? Raise your hand. Aha, very well. Lenka, can you tell us a bit more about the auroras? And we have the northern lights, but you also have the boreal auroras.
Yes. Yeah. Indeed. So I was also raising my hand. I never saw aurora just once in an airplane. I was going from Los Angeles to back to Europe, and I was with my parents, and I saw this aurora from the window, you know, and you want to shout through the whole airplane, like, look, people, there is aurora. They were sleeping and so on. I tried to engage my parents, but they were having their own conversation, and they left me with my passion alone, so I was really with the eye, just observing. I would like to see aurora as well. It's a fascinating phenomena, and it is related to space weather. So when I was saying all those stories that people observed, aurora, northern lights, it is connected to space weather. And the brief explanation is when you have the stream of energetic particles that nicely go around or along the magnetic field lines of Earth's magnetic field, it seems they go away, but they go actually to the tail. And sometimes we can see that the magnetic field line touch and reconnect. When they reconnect, suddenly these particles that were here go and flood the Earth from that side and enter our atmosphere. And when such a particle enters the atmosphere, it hits the atoms and molecules in our air. These molecules and atoms get excited, meaning not that just they were hit and they're excited, but it's really from physics point of view, you receive the energy of the particle and they go to excited state. They don't stay in the state too long, and they go back to their energy state and they radiate a photon of a specific color. So that's why we see those beautiful auroras. There are many different types. I'm not an expert on auroras, but there are many different types. There are even daylight auroras. So yes, indeed. So you can see nighttime auroras, but sometimes, not sometimes, but you can see, especially if you have some device like a camera, you can really observe nice daytime auroras as well. And I like what you said. It's not just northern lights; they appear also on the South Pole and also on other planets as well.
And just for curiosity, the daylights usually you can see it if you are in higher latitudes. And I can give you a tip, inside tip. Abisko in Finland is one of the best places in Europe to see auroras. And indeed, there's a lot of spectrum of auroras that are not visible to the naked eye. So if you go to see it, take a camera, because usually it's how you start seeing them. You start shooting, and then suddenly you see like a huge spot, and then sometimes when you start seeing it, you just see green, but if you look at the camera, you see more colors, so it's actually quite a show. It was my last trip before confinement in 2020. I saw the auroras, and I did some research, and Abisko is one of the best places in Europe because they have their own microclimate, because they have mountains around, so it actually increases the possibility of having clear skies. Because if you have clouds, sorry guys, it's not going to be a very fantastic night. But indeed, you can see it during the daylight. It's already Arctic, so it's really high, and it's quite a show. So save some money because you really need to see it once in your life, and then you will remember Lenka and this talk, right? Space weather is the reason why you will be seeing the auroras. So if there's no more questions, I will just give like 2 or 3 seconds to see if someone raises the hand for a last question. Or maybe from online questions if we have. No? Okay. And here in the room, do we have any more questions? Speak now or forever? No? Okay. In that case, I would like to thank Lenka for being here. I would like to thank you all also for your participation and interest in space weather. It's not every day that we can actually have non-space people interested in these topics, and actually space weather is a very interesting and fascinating topic. I would also like to thank the invitation for me to moderate this event. It was quite a privilege, so thank you very much. And I would like to give you a heads up that there are actually more science cafes like this one, so follow the Facebook page and the social media networks of the organization for the next ones. I'm sorry to say they might not be as fascinating as space weather, but science is always fascinating, so always come and enjoy the event. And I need to say this, otherwise I might not be entitled to the wine. Please stay for a glass of wine and to have some snacks. And of course, Lenka will still be here around to reply to any more questions that you might have. Thank you all for being here, and have a nice evening.